do a quick reminder of percent composition and then kind of walk you through some empirical formula stuff. To find percent composition of something, you just take the part divided by the whole. So if we wanted to find the percent composition of ammonia, now down here they did percent nitrogen, but I'm just talking about percent composition in general. So what you would do is you take the mass of the whole thing, which is a nitrogen plus 3 hydrogens, and that's going to equal 17. So if you want to find the percent nitrogen, you do 14 divided by 17 times 100. If you wanted to find the hydrogen, you do 3 divided by 17 times 100. And it's going to be like that for every compound you do percent composition with. So real simple. If you want to use it as a conversion factor, you can. What they did in this case is we have 82 grams of this compound. So we started with that amount, and we took the percent. We found the percent carbon in this compound, and we found it to be 81.8. So what that means is 81.8 grams out of a 100-gram sample of this compound is going to be just carbon. And so then that allows us to find how much carbon is in that sample. Down here they did it for the hydrogen because it would have been 18% hydrogen, so 18 out of 100. You could also just multiply by the decimal form of the percent, and that would work. So hopefully that makes sense. We've already talked about it, so I just wanted to do a quick walkthrough just to make sure. So an empirical formula is the lowest whole number ratio of the atoms of the elements in a compound. So for instance, if you have hydrogen peroxide, H2O2, that is a molecular formula, but do you see how it's not the lowest whole number ratio? If you go to the lowest whole number ratio, it would be a 1-to-1 ratio, like that. So this would be the empirical formula. This is the molecular formula. That's all we mean by the lowest whole number ratio. So to find the percent composition, there's a couple steps. The first step is you're going to be given percent composition, or you'll have to find it, which if you know how to find it, it's real easy. So you're essentially going to be given percent composition. Then assume a 100-gram sample of each substance. So if you assume a 100-gram sample, you just take the percent and make it grams. And then convert that mass into moles. You'll divide by the smallest number of moles, and then you have to do a little multiplication until you get whole numbers. All of that might sound a little weird right now, but I will show you what I mean with an example. So we have a compound that has 25.9% nitrogen and 74.1% oxygen. So the first step was just to convert it to grams. So assume a 100-gram sample, that means we have 25.9 grams of nitrogen and 74.1 grams of oxygen. Then convert that to the number of moles. So nitrogen is 14 grams in 1 mole. We're just using the single element, not the diatomic version for this. Typically we will use the diatomic version. This is kind of an exception. Oxygen is 16 grams in 1 mole. Okay, so work that out. I get 25.9 divided by 14, 1.85. That's moles. And then 74.1 divided by 16 is 4.63 moles. So what we have now is a ratio of moles. So you have, the 1.85 nitrogen to 4.63 oxygen. Well, here's the thing. You won't ever see a compound written like this. All right, so we got to get those ratios into whole numbers. So what we do is we divide by the smallest one. 1.85 is the smallest in this case. And when you do that, you get 2.5 here and 1 up here. Now, yet again, you're not going to see in O2.5. So we still got a problem there. So to get the whole number, what we're going to do is multiply them both by 2. And that's going to give us 2 here and 5 here. So you got N2O5. You see how that can't be divided down any further? You can't divide it by 2 or anything like that. Can't simplify it. Think of it almost as a fraction, 2/5. You can't simplify that any further. So this would be the empirical formula of the compound. Alright, so more examples, but I'll give you more of those later. So to find the molecular formula is always going to be a multiple of the empirical formula. So like, for instance, back to that peroxide, its empirical formula is this. To get the molecular formula, you would multiply it by 2. So the molecular formula will always be a multiple of the empirical formula. And to find it, you're going to use its molar mass. So find the empirical formula first, and then once you know the molar mass, you will divide the molecular mass, the molar mass of the molecular formula, by the molar mass of the empirical formula, and that tells you how many times to multiply by. Now, once again, I know that was a lot, so let's just look at an example. So find the molecular formula of ethylene glycol, which is used as antifreeze. The molar mass is 62 grams per mole. And look, they already got the empirical formula. Typically, you're going to have to solve it, but in this case, they already got the empirical formula. This is the molar mass of the molecular formula. So what you do, find the molar mass of the empirical formula. So that'd be 12 plus 1 plus 1 plus 1 for each of the hydrogens, so plus 3, then plus 16 for the oxygen. You should get 31. So the empirical formula's molar mass is 31. So 62 divided by 31 gives you 2, which means to get the empirical formula, to get the molecular formula from the empirical formula, you multiply the whole thing by 2, so you'll get C2H6O2. And once again, you can see how this can be broken down to get this, if it's like a fraction. So that's how you would find the molecular formula. Obviously, like I said, they're not always going to give you the empirical formula. You might have to calculate that first, but they will always give you this if they want you to find the molecular formula. I hope that kind of helps. I'm going to make another video about some practice problems, so look for that if you need extra help.